everyone. Today we're going to continue on with the lesson. We're going to learn the second part of it, and then we're going to throw those both together as in one big practice worksheet, and then we'll do a worksheet with a grade. So let's kind of learn and go over your homework, and then continue on to part 2. So I just want to bring up this solubility guideline table. You received this in class. Here you have your soluble. Note that it always gets the abbreviation AQ. Insoluble, it gets the abbreviation S for solid. There's a couple things I asked you to add to your table, and that is ClO4 -1 and then ClO3 -1, and both of these have no exceptions. Again, as a general reminder how this table works, you want to find your anion. You would see if it was bonded to any exceptions. If it was not, then it stays in the category it's at, so it stays soluble. If for some reason it was bonded to an exception, then it would flip to be down here and it would be insoluble. So let's go over your answers for your homework. So for your homework answers, the first one says, predict and identify the precipitate that forms when solid solutions of barium chloride and potassium sulfate are mixed. First, let's go over what a precipitate is. Remember, a precipitate is a solid that forms when we mix two aqueous solutions. So here, both of these solutions are said to be aqueous. And so what happens when we mix them? First thing that I taught you was to split it apart into its ions. So hopefully you split this apart into a Ba2 plus ion because you uncross this 2. This one you slip into a Cl -1 because you uncross that -1 charge. And then again, make sure you check to make sure it wasn't reduced. Cl should be a -1, so that is good, and barium's good being a 2 plus. Over here, we're going to split it into its 2 ions. So I uncross my charges. This one can go up on sulfate, so SO4 to negative. This 4, remember, you cannot uncross it because it's attached. So it's actually an understood 1 that gets uncrossed. So this is a K plus. From there, you check it. Sulfate should be a 2 negative. Potassium's good being a plus, and so both of those are fine. Then what you want to do is you want to recombine these in a way that doesn't get you your original starting basically chemicals. So instead of barium being with chlorine, barium's going to attach to the negative sulfate. So we're going to go ahead and cross this. Originally, a 2, you will get Ba2, you'll get SO4 with a 2 on the outside. But remember, I'm crossing a 2 negative and a 2 positive, so those cancel, and you get a BaSO4. Over here, my positive ion is going to combine with my other negative ion. As a general reminder, write positive ions first. So here you get a K, a 1 drops down there, Cl, and the 1 drops down there. So my 2 things that I get are BaSO4 and KCl. From there, you have to determine if a precipitate forms. So on here, you would have to find SO4 on your chart and then see if Ba is an exception. So if I look at my chart, here's SO4. Ba is an exception, so it actually moves to be down here in this category, and that tells me that it's an insoluble solid. So it is actually a solid. This tells me that this one should be my precipitate. Let's just go ahead and check the other one just to double check ourselves. KCl, I would find chlorine and see if K is an exception. Here's my Cl. K is not an exception, so that means it's going to be AQ for soluble. So this one actually gets AQ. If we identified our precipitate, it would be BaSO4. On the second one, same thing. What compound is going to precipitate when we mix these 2 solutions? So again, let's split them apart into their ions. Here, Fe should have gotten, if you uncross this 3, a 3 plus. The 2 leaves and the 2 goes up here, so you get an SO4, 2 negative. Most common mistake I see people do is they leave that 2 down there, but remember that 2 shouldn't go there. It's not originally there. We have to uncross that. Here, we're going to uncross lithium and a hydroxide. Oh, before you do that, make sure you check, and those are both good. Here, if you uncross it, lithium gets a +1 and hydroxide gets a -1. You check it, they're good to go. From there, you need to recross them. The positive will go with the negative. So when you cross them, you get FeOH3. Here's where a lot of people make a mistake. Remember, you're crossing something down on a polyatomic, so do not forget your parentheses. On the other one, lithium combines with sulfate. So Li, the sulfate drops down a 2. Sulfate stays SO4, and you're dropping down a 1, so you don't have to write it. Li2SO4. From there, you need to check to see if any of these form a solid. So I need to find OH and then see if iron is an exception. If I look back here, I have an OH. Iron is not an exception, so I stay in this category and say that it is a solid. So this forms a solid. This would be our precipitate, so I'm going to go ahead and circle that as our answer, but let's go ahead and check lithium sulfate just in case. So here's my sulfate, and let's see if lithium's an exception. So here's my sulfate. Lithium is not an exception, so I can just go ahead and say this is AQ or soluble. Okay. And the last one, it's asking, will a precipitate form when barium nitrate and potassium hydroxide are mixed? So here you have to see, is this reaction even possible? Again, no precipitate equals no reaction. So let's split this apart. Here you should have gotten barium with a 2+, and then nitrate with a -1. Here, potassium should have gotten a K+, and hydroxides a -1. If you're still struggling splitting your ions, please make sure that you come and ask me any questions that you have, and we can work on it, and I give you extra practice problems. So here my barium works with my OH. So my barium and then my OH, I'm dropping a 2. It's dropping on a polyatomic, so make sure you have those parentheses. My potassium is going to combine with my nitrate, so I get KNO3. Now I need to check these, OH, and see if barium is an exception. Here's OH as an insoluble, but barium is an exception, so that flips up to be up here, which is soluble AQ. So this one is going to be an AQ. Over here I have nitrate and potassium. So here's my nitrate. There's no exceptions, so that one stays in this category of AQ. So will it precipitate form? Well, we're looking for that solid, so no, because I didn't get a solid, so no precipitate. If you struggle with this homework, please make sure you contact me. I can set up a Google Meet. We can go through any of this. Otherwise, let's just go ahead and get started with today's lesson. As a little precursor, if you're one of those people that need to listen while I'm talking and you can't do that while writing, please just pause this video, write down anything that you need to, and then unpause it and you can listen to say what I say about it. First and foremost, this slide is a lot of introductory slide. It has definitions. You do not necessarily have to write down these definitions. I will not ask you about them, but you will see them in the questions, so you need to be familiar with what do they mean. On the next slide, I will provide you a physical example of each one, so you kind of understand and have something to refer to when I look at them. So in writing equations for reactions for solutions, it's often helpful to indicate whether a substance that is dissolved, is it predominantly ions, or do they tend to stay together as a whole molecule? Well, we usually represent this using different equations. The first one that most of you guys are familiar with is a molecular equation. And this is the one that you guys have seen all year long, where I give you a chemical formula of the reactant and products. The two new ones are ionic and net ionic. What an ionic equation is basically it takes any strong electrolytes that are those compounds. Remember, that includes strong acids, bases, and ionic salts. And what it does is it splits them into their ions. So they're written in a form in which all the ions are split apart. Notice that it says here soluble solids or soluble ionic salts. So these are things that have to have an AQ. Your net ionic equation is whatever ions are duplicates, then we tend to cross those out and rewrite everything that is left. So we cross out anything that does not change from the left side of the equation to the right. And if they didn't change, we call those spectator ions. And again, we just cross those out. Everything else is rewritten. If that sounds confusing, let's go through an example and see what you think after that. And then again, if you have questions, make sure you ask. So here's an example of each of the three. This is something that I told people in class to write down. The first one is an example of a molecular equation that you've been seeing all year long. Here you have a whole compound. This tells me that it's a solution. Whole compound, it's a solution. Here's a compound, but it's a solid. And another one, it's a solution. Down here is my ionic equation. Before I explain it, I have a couple errors that I want you to fix. First, NO3 or NO should be a 3 negative 1. So down here, please fix this to be a 3 bottom and a negative 1 on top. Now that we've kind of fixed those errors that I made, let's go through what happened. What happened is this compound is an aqueous. It is a strong electrolyte because silver is a metal. So it splits into the ions. Silver becomes a +1. Nitrate is an NO3 -1. Here's my potassium chloride. It is aqueous, and there's a metal that tells me it's a strong electrolyte. So what happened is it splits into K+ ions and Cl- ions. Here's my little arrow. Down here, these are my products. I have AgCl. Notice here, it's a solid. If you ever see a solid, I'm going to tell you, and it's going to be on the next slide, you can't dissociate it because you didn't dissolve it. So solids here is written as AgCl. It's a solid. And then KNO3. This one is aqueous, so I'm good to go. And I can split it because there's a metal. So it splits into K+ and NO3 -1s. From there, you have to see, well, what's the same on both sides of the equation? Well, on my left side versus my right side, they both have NO3, so I can cancel those. They also both have a K+, so I can cancel those. And then you rewrite whatever's left. So I'm left with a silver positive ion, a chlorine negative ion, and then AgCl as a solid. So this is my net. Anything that you crossed out, those are called spectator ions. So that NO3 negative you crossed out and that K+ that you crossed out, these are spectator ions. That means they don't really participate in the reaction, they're just there. Here is the word format of how do we write net ionic equations. The first and foremost thing that you need to do is make sure that your molecular equation is balanced. We worked on balancing last semester, so I do expect you to know how to balance for this semester. The second is we want to dissociate all strong electrolytes. So whenever you hear the word dissociate, it means break apart. So split them, split the ions. Note that it's only strong electrolytes. If it's something that is weak or a non-electrolyte, you do not split those. The other thing is solids, liquids, and I'm going to add and gases do not dissociate. So if you ever have something in a solid, liquid, or gas phase, you do not split those apart. You can only split apart things that are aqueous. The next one is the most complicated one for people to grasp, and that's what happens for subscripts. So any subscript that was dropped down as a charge on a compound, which means it doesn't normally belong there, actually becomes the coefficient. What that means, for example, MgCl2. Chlorine doesn't normally have a 2 down here. That 2 came from magnesium's charge. So when we split it into its 2 ions, Mg gets a 2 plus, but that chlorine, that 2 that was written down here that doesn't belong, gets put out front here, and we have 2 chlorine ions, so 2 Cl negative 1. Well, what happens if there's already a coefficient in front? Well, what happens is if there's a coefficient already in front, we multiply the number with the coefficient's number. A good example of this is 2H2O. Well, you could say that here this 2 does not normally go on a hydrogen. So 2 times 2 gave me 4 hydrogen ions, so 4H plus. And then here my oxygen, I have that coefficient out front. I have 2 oxygen with a 2 negative ion. This gets a little confusing, so I'm going to do an example, and hopefully you follow along. Again, if you don't, please make sure that you ask. Once you've split it apart, then you cross out anything that remains unchanged or is the same from the left to the right side of the equation, and then whatever remains is going to be your net ionic equation. If for some reason every single thing crosses out, no reaction occurs. Again, another way you can know if a reaction occurs or not is if you do not have a solid, you do not have a reaction for precipitation. So let's go through 2 practice problems, and I will have you do the other 2 for homework. The first thing, it says determine the net ionic equation of the following reaction by writing the molecular and complete ionic equations. Well, one, here is the molecular equation kind of written, so we just have to finish it out. Generally on your homework, I will give you the 2 products, or not 2 products, 2 reactants. You will have to split it apart into its ions to tell me what the products are going to be, like we did on our homework. Luckily, I've already done it here. When sodium bromide and potassium iodide are mixed, it will form potassium bromide and sodium iodide. What I want you to do is here in the parentheses, tell me whether it's going to be an aqueous solution or a solid. So you're going to have to get out your little chart. Here, I'm going to look for bromine and then see if potassium is an exception. So if I go back here, I find bromine. Potassium is not an exception, so that means it's going to be AQ for soluble. Right, an AQ. Here I have iodide, and I have to see if sodium's an exception. Here's iodide. Sodium is not an exception, so that means that it's going to be AQ as well. Once you see that both of these are going to be AQ, that should click in your head. This is not a precipitation reaction, so no reaction, or basically no precipitate. If I asked you about this, this would not occur because there's not a solid that is formed for this precipitation reaction. You will have one on your homework in which will be no reaction. Here's the other practice problem. Here we're going to make the products to kind of show you what I expect out of you guys, and then we're going to write it. I want you to please note that this one is actually one of the harder ones. I decided to do it for practice, so that way if you guys had any questions, you guys could ask. Here it says determine the net ionic equation of the following by writing the molecular and the complete ionic. We just have to finish out the molecular. First things first is I would split apart your ions. So this one splits apart into strontium, which is a 2+, and then over here nitrate, which is a 3, and then if you uncross that, -1. Here, this one splits into K+, because that 3 doesn't normally go there. It uncrosses to tell me PO4 3- is my actual thing. From there, I have to recombine. So remember, strontium is going to go to my phosphate over here. So I get SR3, because that 3 drops down, PO4, and since I'm dropping down a 2, I got to put parentheses around this to get my answer. Here, potassium is going to form with nitrate. They both have a +1, -1, so you can just write KNO3. From there, you have to check on your solubility table whether this will be a solid or an aqueous. If you checked, PO4 is actually located under the insoluble. Strontium is not an exception, so this actually comes out to be a solid. NO3, that is located in your soluble section. K is not an exception, so this ends up being aqueous. Once you have that down, the first thing, if we go back to our rules, is to balance the chemical equation. If you were to balance this, you would hopefully get 3, 2, 1, 6. Once you balance it, we need to start splitting things into the ions, and this is where most people get caught up. So please, if you're writing, make sure you pay careful attention. This right up here is your molecular, so the next one I'm going to write is my ionic. First, you start out, I know that strontium is a 2+. I wrote it here. Strontium is a 2+. What I need to figure out is what my coefficient would be. Well, here, there's nothing down here that doesn't belong, so that's fine. But I have this 3 out front, which tells me that there is 3 strontium. So I'm going to put 3 strontium ions. This is all in a solution, so I'm going to still keep that aqueous. We're going to add this. The next one we have is nitrate, NO3, and note it has to be an ion, -1. If I look at this, NO3, this 2 does not belong. So what happens is this 2 gets thrown out front. So 2 times 3 is 6. Again, that 3 doesn't get touched because NO3 is a pact, it's a unit. That 2 was the charge that got dropped down, so that 2 becomes the coefficient. This is still in an aqueous solution. From there, I have a K+, so I have to look. This 3 doesn't normally belong down there. It came from the charge on phosphate. So this 3 gets thrown out to the front, and this becomes 3 times 2 is 6 potassium. Next, we have phosphate. Well, here a lot of people would write down phosphate, and they would say that my coefficient is 8. But this 4 belongs here, so we can't move it, we can't touch it, we can't do anything. So right now, phosphate actually just has a 2. From there, we have our arrow, so I'm going to go ahead and draw my arrow, and I have this compound. Well, this compound is a solid, so I am not allowed to split it. You have to write it exactly as is. So we write it as strontium phosphate as a solid. We don't change anything about it. This one, on the other hand, is AQ, and it's a strong electrolyte, so we're allowed to split this one apart. So if we split it apart, we already know that K makes a K plus. There's no number down here, so I don't have to worry about moving that, but my coefficient over here is 6, so 6K plus. The next one is NO3, and most people can tell me this has a -1 charge. This 3 belongs down here, so I don't have to move it. I can't move it. But this 6 applies to everything, so this is a 6 NO3. And this is AQ. Once you have it all written out, the way you write down the net ionic is to cross out whatever is the same on both sides of the arrow. So most people will tell me that there are 6K plus on both sides and that there are 6 NO3s on both sides. Here, this is strontium, but this is an aqueous, while this is strontium as a solid, so I cannot cross those out. Once you've crossed out everything, or you've crossed out your spectator ions, you can write what's left. So here, 3 plus your phosphate yields your strontium phosphate compound. And then you are done. Nothing more because it's already reduced. So this one right here is going to be your net ionic equation. Now I know that was a lot, so if you struggled at any point, make sure that you ask me questions. I'm going to give you a little bit more practice on this stuff because this is completely new. But until next time, please let me know if you need anything, and I hope you guys have a great day. Oh, sorry. Homework, here's one homework problem. I have it posted on my website. And then here is the other homework problem. I have it posted on my website. These are both completion, and I will send out the answers tomorrow. Otherwise, now I hope that you guys have a great day.